Hi and welcome to another video, and in this video we are going to introduce two more methods of differentiation, that is differentiation of implicit functions and also differentiation by use of parametric equations. If you haven't checked the other videos, that is differentiation by chain rule, differentiation by product rule, and differentiation by quotient rule, check them on the link shown here or in my video description here. Now let us get to the task. But what is an implicit function? An implicit function is a function in which the variables, the dependent variable y and the dependent variable x cannot be completely separated. That's an implicit function. It's not possible to put all the values of x, the x on one side and the y on one side. Now, for example, here I have a question. This is diploma. Diploma in building and civil building technology and civil engineering are one. Building technology and civil engineering are usually offered in same department slash architecture. They are all offered in the same department, so even the mathematics, they just sit for the same paper. Now, this is the July 2020, and here we are told determine the derivative of the following functions. Question 3 here. Determine the derivatives of the following functions. We have 1a, Roman 1 is 4x squared y power 7 minus 2x is equal to x power 5 plus 4y cubed. So if you look at this equation, it's not possible to completely separate the values of x and y because of this term here that has 4x squared and y power 7. We bring all these terms to the other side. We have x squared y power 7 minus 2x minus x power 5 plus 4y cubed is equal to 0. Then you can differentiate through with respect to x. So if you differentiate this whole of this expression with respect to x, this is 4x squared this y power 7 minus 2x minus x power 5 plus 4y cubed is equal to 0. Okay, we are differentiating that with equal to 0. Of course, even the other side, if you differentiate 0, it will give us 0. Now, notice y is a function of x. Y is a function of x in this case. So, if y is a function of x, 4x squared is differentiable with respect to x. Y also is differentiable with respect to x because it is a function of x. So, here if you have to differentiate, you have to use product rule to differentiate this expression. And no, what do you get when you differentiate y with respect to x? You simply get dy dx. What if you had y squared and you are told to differentiate this with respect to x? differentiate y squared with respect to x. You will differentiate the normal way you do to get to y. But now, because y is a function of x, you're going to add a dy dx here. Because you are differentiating y, which is a function of x. So it is 2y dy dx. So that's the trick we are going to apply here. Now, when you are differentiating this part, remember you are going to use product rule. Product rule, we said yes. Product rule, we said in a previous video. If you are given y, you are told to differentiate this. It is u take b differentiated plus b take u differentiated. So if you take this to be our u, then here it will be 4x squared. Then we take b differentiated. Let us take this to be our b, and then we differentiate it. If you differentiate y to power 7, it will be 7 y to power 6. But because y is a function of x, we are going to add a dy dx. Now, so that part that we have evaporated is uv prime. We now need to write the other part, which is y is our b. Y to power 7 is our b. Then we differentiate this with respect to x. It will be 8. 2 times 4 is 8. 8x. Then next is this part. This is only one term, so we just differentiate directly with respect to x. So it will be minus 2. We differentiate this with respect to x. It will be minus 5x power 4. Then finally differentiate this with respect to x. It will be plus 12. Because 3 times 4 is 12. Y squared. Y squared. But because y is a function of x, we are going to add a dy dx. So that's how you go about differentiating that part. This should be equal to 0. We are going to put all terms that do not have a dy dx on one side. So let us multiply this 7 and this 4. That is 28. 28x squared y to power 6 plus 12y squared dy dx. Everything that does not have a dy dx, we put it on the other side of the equation. So we have, I'll start with the positive one. 5x power 4. Let me start with the one that have x and y's. Y to power 7 x. So you have taken care of this one. You have taken care of this one. You have taken care of that one. You have taken care of that one. So you are only left with this plus 2. Now here you factor out dy dx. 4 dy dx into 7x squared y power 6 plus 3 y squared is equal to 5x power 4 minus 8y power 7x plus 2. We want dy dx, so you are going to divide everything that's not dy dx. You are going to divide on this side and on this side. So finally we have dy dx is equal to 5x power 4 minus 8y power 7 x minus 8y power 7 x plus 2 divide with this 4 into 7x squared y plus 6 plus 3y squared. So that's how you go about that one. Notice first, you have to check whether it is possible to separate all the y's on one side and all the x on one side. But even when you have an equation like say y squared, if you have to find the root, it will be positive or negative y. So if you had something of the sort is equal to 7, you cannot say this is y squared equal to 7 minus x squared. You are going to differentiate the norm way. No. You also, in this case, you also have to use implicit, differentiation of implicit function, because if you are not to get the value of y, it will be plus or minus root of 7 minus x squared. So again, we cannot associate y to either of these. Again now, because we can not associate y, we are not sure which one to associate y with, whether plus or minus, then in this case, we say we cannot be able to completely separate y's and x's, and we call this an implicit function. If it's possible to separate y's and x's, that function is explicit, and in that case, you just use the normal way we differentiate. For example, y is equal to 3x squared minus 7x plus 6. This one is explicit because you can see all x's on one side, all y's on one side. So we don't need to use differentiation using the implicit method. You just go ahead and differentiate directly the way we have been learning all through. Now we are going to attempt another question. Diploma, electrical engineering, June July 2022. We have 2A, Roman 3. I think that one we had done in a previous video. That's why it's good to check all my videos. I usually organize my videos from lesson 1, lesson 2, lesson 3, up the last lesson. So it is important when you're watching my videos, start from lesson 1, lesson 2, and so on, unless you're able to grasp concept in a different video when you have not started from the very first video. Now, we are given here, we are told to find dy dx, given that 3 x squared y plus 8y squared plus xy squared plus y cubed is equal to 0. X squared y plus xy squared plus y cubed is equal to 0. Is it possible to separate all y's on one side, all x's on one side? If you had factor out x, you'll be left with an x squared, with an x here. If you had factored out y, you'll be left with an y here. So it's not, for this one you can take it to the other side, yes, there is no problem. Now again for this one, you will not be able to completely separate them. Now, for that reason, we are going to differentiate it. It will be d, derivative with respect to x. Because you are told to find dy dx, we are going to differentiate with respect to x. X squared y plus x y squared plus y cubed is equal to 0. Notice, x on its own is differentiable with respect to x. Y is differentiable with respect to x. So in that case, we have to use product rule. if you are told to differentiate y is equal to uv, and now I'm not going to use variable y. Now I'm not going to use variable y because we are already using it. I'm going to use another variable w. And if both u and v are functions of x, then derivative of w with respect to x is u, v differentiated with respect to x plus v u differentiated with respect to x. I think we have already stated that in a different video. Now, I'll take this one to be my u, this one to be my v. First, you take u the way it is, x squared, differentiate v with respect to x. If you differentiate y with respect to x, it is dy dx plus v, my v now is y, differentiate u with respect to x. What is our u? U is x squared. So if you differentiate that, you get 2x. So you're done with this part. Again, notice this one also. You can only differentiate using product rule. Because x on its own is differentiable with respect to x, and y squared is differentiable with respect to x. So again, we are going to apply product rule. That's why you needed to do product rule before you do other method of differentiation plus chain rule. They are very applicable in other areas. The first one, you just take x the way it is because it's on u. X. You take u the way it is. Differentiate y with respect to x. If you differentiate y squared with respect to x, it will be 2y. But since y is a function of x, then you have to add dy dx. So we have evaluated that to v prime. Now we move on. We evaluate v, or v is y squared, v u prime, and then differentiate our u. Our u is x. Differentiate x with respect to x. That one is 1. Then we move on. So you can see these two terms have given us 4 terms. These two, when you apply product rule here, and these two, when you apply product rule here, then differentiate the last one. If you differentiate y cubed with respect to x, to be 3, differentiate the normal way you differentiate y squared, but since y is a function of x, you have to add a dy dx. So that's how we go about that one. Now what you are going to do, all terms with dy dx, we're going to put them on one side. All terms without dy dx, we will put them on the other side. So here you have x squared dy dx plus this one 2xy, this one dy dx plus which other one? This one dy squared dy dx is equal to, this one doesn't have an x, negative 2xy, this one minus x minus y squared. So we have taken care of that, and that. We also taken care of that, and that, and that. So we have taken care of all the terms. Next, we are going to factor out dy dx here. Dy dx, we factor it out. Here you have x squared plus 2xy here plus dy squared. On the other side, if you want, you can factor out the negative 2xy plus x plus y plus y squared. Now all you have to do is divide. We want to get rid of the dy dx on this side, so you're going to divide both sides with this term. Now you have dy dx is equal to negative 2xy plus x plus y squared all over x squared plus 2xy plus by squared. So that is it. That's how you solve such a problem using implicit functions. I think we are going to do another problem later, but I would like us to introduce another method, that is differentiation using parametric equations.